Let x1, x2 and so on xn be a random sample from uniform 0 minus theta minus half to theta plus half. Which of the following statements are correct? So first statement says x1 comma xn is sufficient as well as complete. So for that, like, we can consider for sufficiency, so we can consider the likelihood. So likelihood is theta belongs to I is equals to 1 to n xi minus half comma xi plus half, the intersection. So that means it is nothing but xn minus 0.5 comma x1 plus 0.5. So that means the likelihood depends on the data only through this x of 1 and x of n. So therefore it is sufficient. In fact, like, it is minimally sufficient. This x1 and xn are minimally sufficient. X of 1 comma x of n are minimal sufficient. So now, like, in order to check the completeness, so completeness would mean, like, that means there should be a measurable function z of this x1 and xn that satisfies expectation of this z of x1 comma xn is equals to 0 for all theta. So that means z must be 0 almost surely. So now, like, we can, like, this generally fails because, like, if we consider the joint distribution of this x1 and xn, this is just a location shift of a fixed distribution. Like, for example, if I write x as some x of 1 minus theta and v as some x of n minus theta, so u comma v has, if you find the distribution of u comma v, so that is having a distribution independent of theta. So that means, like, if I find z of x1 and xn, so let's say that is the expectation of z of u plus theta comma v plus theta. So if you pick any g that depends only on the difference v minus u, so let's say if I consider z of x comma y is